All right, so we got to our terrain renderer um, last episode, and what we need to add now is our renderer layer so that we can create a render stack, the same as we're doing with our layers. So the first thing we'll do is make a iRender layer. So the iRender layer will go into our core. I layer render. So this is going to be class name, not like that. Class name, I layer renderer. Okay, look. What we're talking about here is going to be an optional rendering contract. It's a layer that also wants to draw on screen. Okay, should extend both iGrid layer and iLayer renderer via composition or a combined subclass. Then register itself with the renderer stack separately. Okay. So usage is like this. Grid.renderer add renderer terrain my terrain layer. We're going to have a Z index. Then we might have another layer like renderer.add renderer, let's say a heat map. Okay, so my heat map layer, and that Z index, it's going to be 10 because we want it written on top. Stuff like that, right? Pretty cool. Pretty cool. Now, all right, what are we going to do in here? Well, we are going to draw order. So it's going to be lower equals drawn first by beneath the layers at the same Z index. Bar Z index n equals 0. So layers at the same Z index are drawn in the registration order. All right, so if they're at the same index, they're just going to be drawn as in the order that you register. The dirty bull equals true. So this guy, brother, true. So this set to true when underlying data changes. render stack skips clean layers. And then we're gonna do a var render p. That's gonna be a string. We equal at that. So this is gonna be the key. This render is registered under. Cool. So some lifecycle functions that we're going to need are func on renderer registered. Third. It's going to be a grid. It's going to be just grid map. It's going to be a void. And of course, we don't do anything. We're also going to have the function on render unregister registered. That's going to be a void, and we do nothing. So we're going to have a few overrides for your rendering layer, right? So draw. That's going to be a viewport rectangle, rectangle 2, and canvas, canvas item. It's going to be a void. It's going to be dirty equals false. Right, so draw this layer. Canvas is the canvas item to draw on. Yeah. Only called when 30 equals true. Set 30 equals false when done. Yep. Okay. Next is function mark dirty. It's going to be a void, and that's going to make 30 equal true. So force a full redraw next frame. Cool. And probably we need mark fill dirty code. That's going to be a void 30 equals true. Yep. So what do we do here? Mark only specific cells as dirty. All right. So then we can just like render a specific cell if we need to. So the next thing we need to look at is our render stack. So it's going to be pretty straightforward. Create a new render stack. So it's class name render stack. Let's rename that render okay. We just have the grid. just grid, and we just have a function called init grid grid map. Cool. It's a void grid equals grid. Cool. So what are we going to call this? Owns all the I layer, renderer instances, draws in ascending Z index order. Okay. So the next thing we need is our render stack. So render stack, that's going to be a class name render stack. We're going to have a little like internal class here, and it's going to be called a render entry. Okay, it's going to have a var key is our string, and a var renderer, which will make a variant. Then we're going to have a little function here called init a string variant void p equals k renderer equals up. Okay. So it's going to be like the grid spread map. The var will be the entries. It's going to be an array of the renderer entry. Render. Yep. Equal that. Cool. Dirty order. So that's like that function init grid grid map void grid equals grid. Cool. So now for our registration, we just go add render that'll be like a key string render variant z order int equals 0 by default, void add a renderer if as renderer key push warnings render stack overriding renderer percent s and it's just like percent key. All right, remove renderer key. So we just remove it because we're overriding it. I'm going to add this new one that we're putting in there. So renderer z index equals 0 and that equals z. Renderer dot renderer key equals the key and renderer on render registered. It's going to be the grid. Okay. We haven't got that function has renderer yet. Don't worry, we'll make it in a minute. Remove renderer key string. And it's going to be a void. Okay, for I in entries dot size if trees I key equals key entries I dot render dot on render unregistered entries dot remove that. Right. Alrighty. Alrighty. Is that all we have to do? Then we, of course, we already found it. Function has renderer key string, and we return a bool for the in entries if a key equal key return true, else return false. All right. Render renderer. Okay. Get node notation is no good. No. Remove renderer. Renderer. Cool. All right. That's how we register the stack. Now we're going to get into the actual drawing. Function render viewport rect 2 and a canvas item. All right. First, we ensure sorted. Let's make sure we keep everything in the right order for the entry in entries. Variant entry if dirty draw view around canvas we'll fix that in a minute. Mark all dirty void for entry and entries entry in entries entry dot render dot dirty equals true mark 30 key string void equals renderer key if 30 equals true. All right. All right. Set the Z index. Key string Z int. It's going to be void. I'm just going to do equals get renderer key. Render key. Okay. If r dot z index equals z 30 order equals, yep, so we got to resort. We got to redraw everything basically. We change the z order or something. So ensure sorted will be like this, if not 30 order return. Entries sort custom function render entry b render entry return a render z index b render z index. Expected end of file. Entries dot sort custom function something's not right here. And array string ensure sorted var out array string equals that for e in entries out of 10 percent s z equals percent a. What are we doing here? It's gonna be the key and the render z index. We just return that. Cool. So identify a viewport is viewport is cool. Get render is not a function. Get render is not not a function. We as render. Get render. P string layer renderer. No question. For a in entry if b key equals key return e dot return e dot render cool return no. All right. Render. Yep. Okay, everything's cool. That's our rendering stack. Now I think all we need to do is actually put it into our test scene. So let's have a look here. In our test scene, in our ready method, how about we do this? How about we, okay, so we're setting up the renderer here. How about we set up renderers here. Okay, let me just grab that. Let me just make that a little function. Interesting. So we still set them up. Okay. So for now, let's just go function set up renderer. Just won't do anything for a minute. Set up renderers. Let's make a new renderer called our grid grid lines. Something. So that we can like see our grid grid lines, yeah. So the way we do that will be super simple. We add a child node, which will be a 2D. Yeah. And we call that our grid line render. Okay. Do we want that part of our core renderer? Yeah, why not? So we'll just create a new script. Grid line ren and we put it on there. Okay, extends node 2D. Okay. Once line color equals color 1.0, 1.0, 0.0. We want it to be a bit transparent. We'll take the grid as a variant. In our setup, we will take the grid, the variant, and will be a void. Grid equals grid. Redraw. Okay, fine. Draw. Put that in as void. If not grid, then we just return. Grid dot width. H light CS vector 2 grid cell size for x and w plus 1 top vector 2 grid cells to world grid coord new x0 minus the vector to cell spacing times 0.5 cell spacing y times 0.5 and the bottom of the cell is going to equal the top plus vector 0 height times so y. Draw line top bottom line color line but we didn't make it line once width equals O. I should be enough. What's going on there? Vector 2. Okay. For y in h plus 1. We want to look at our left, which will be our vector 2 grid cells to world grid coord new code y minus the vector to is it going to be the same? I think it's the same thing. CS.x times O 25 CS.y and top corner but right is going to be it's going to equal left plus vector to CS yeah. W is not found. I think that's going to be multiply. Draw line left, right, color, line width. All right, that's our little renderer. So in our main test scene, we want to get the grid line render. So we want to go on ready. Grid lines render node to d equals grid line render. Could not find node. Make it 2D. Okay. Nice, nice, nice. So somewhere, yeah, grid. Grid lines. Spot it wrong. Grid lines are going to set up grid. And we'll just make it visible by default. So grid lines renderer dot visible equals grid. Make it a little fun, a little thing here. Code show grid equals false. So, okay. Lines. Okay, so we should see grid lines. I don't see any grid lines. Why not? Redraw all. Now redraw all. We probably gotta actually draw the bloody thing. Well, actually, Did I make it false? I made it false. Oh, right. Okay. So I guess we got to put the input for the toggle in. Yeah. So in the input, we're doing a bunch of things. Okay. G show grid equals not show grid. So we just toggle it. And then grid line renderer visible show grid. Cool. And we crashed. Cells to world in the base. We don't have cells to world. In the grid map, cells to it's pretty. We should make this bloody thing. What do we make this just grid? The hell was I thinking making it a variant? When we hit G, it doesn't seem to be doing anything. Well, let's see if our grid. Okay. So, do we have a grid? Step over that. Top, bottom. I mean, everything's there. Why are we not seeing it? Is it too? All right, and now we run it, and we can see our nice little grid lines. Very nice.